In this video, we'll be having a look at the following integration problem from the HSC Maths Extension 2 2019 exam, question 15a. The first part is to show that the integral from minus a to a of f of x over f of x plus f of negative x dx is equal to the integral from negative a to a of f of minus x over f of x plus f of minus x dx. This is supposed to apply for any functions f of x and any value of a. So let's have a look at the first part. So some quick observations. The main difference between these two sides is we have an x on the left hand side and a minus x on the right hand side in the numerator. What we could do is to try to convert this x into a minus x. And what I've got here is using the u substitution of u equals minus x. If you do this u substitution, first thing we can do is to change the bounds. So the x equals a bound over here will become u equals minus a, and the x equals minus a bound over here will become u equals a. And also we have the dx over here. So if you take the derivatives, du will be the same as minus dx. Now we can write the left-hand side. Write this left-hand side as the integral from a to minus a, and now x becomes minus u, and we also have minus x becoming u, and the dx becomes minus du. So now we have this integral over here. So we can move the minus sign. Out to the front over here now, and now the right hand side is in terms of x rather than in terms of u. So since u is just a dummy variable, it doesn't really matter what's the actual variable we use here. So we can actually change it back from u to x. So now we can just replace the u's with x's again, and now we will end up with this integral over here. And finally, on the right hand side, we can see they want bounds going from minus a to a, but currently what we have a to minus a, so we can flip the bounds, but when we flip the bounds, we also have to take the negative of what's inside the integral. So what we can do is we have a negative here, and if we flip the bounds, this also cancels out this negative sign over here. So we'll end up with the integral from minus a to a of f of minus x over f of minus x plus f of x dx. Okay, and since these two are equal, this completes the first part of the question. So you can just recall these two left hand side and right hand side are the same, except for the numerator with the x being replaced with a minus x. So this successfully completes the first part of the question. So now we can have a look at the second part, where this is an application of the first part of the question. So we have to evaluate the integral from minus 1 to 1 of e to the power of x over e to the x plus e to the minus x dx. So what we can do here is apply the first part. We can let f of x be e to the power of x and a being equal to 1. And we can let I equal the integral we want to calculate. So if we replace 1 with a, we have a over here. And if we replace e to the x with f of x, we'll have f of x's and f of minus x's. So now we have, this is the value, okay, so now using part I, this is another way to write the integral. So remember, we can replace the f of x with f of minus x and we'll still have the same value of the definite integral. So we can write the integral from minus a to a of f of minus x over f of minus x plus f of x dx. And this will still equal the capital I integral. And if we substitute all the values of f of x and a back, we'll now have the integral from minus 1 to 1 of e to the minus x over e to the minus x plus e to the x dx. This is almost the same as what we had over here, except now there's a minus x over here instead of an x. And now we have some symmetry going on. So what we could try to do is to add these two different expressions for I together. So we can write 2i as I plus I, but we'll use the two different expressions for each occurrence of I. So over here I'll use the original expression for I, and over here we'll put the new expression for I over here. Now the sum of two integrals is the same as the integral of the sum of these two inner expressions, and we have two of the same denominators here, so we can just add e to the x and e to the minus x. Now we can see the numerator and denominator are now equal, so now this whole expression will just equal 1. So we'll just have the integral from minus 1 to 1 of dx, and antiderivative of dx is just 1, so it's just x. So that means we have x going from 1 to minus 1 to 1, which is the same as, that's 1 minus negative 1, which is 2. So now 2i is going to be equal to 2. And dividing both sides by 2, we finally get the value of the original integral is equal to 1. So that was quite an interesting proof. We used some symmetry by applying the first part, and we used the trick of adding the two expressions together to get the integral of 1. To just get the integral of 1 dx. This completes the proof of this HSC Extension 2 maths problem. So hope you enjoyed this video. Thanks for watching, and I'll see you next time.